Good afternoon. I hope I'm like audible, visible, and my screen is also shared.
Yes, sir. Audible and visible, and PPT is also visible.
All right. Thank you. Okay. Good afternoon, dear learners. Welcome to the eighth lecture on the course Fundamentals of C. And today we are going to discuss the topic of arrays. My name is Shirish Nagar, and we will begin the lecture. The guidelines for smooth conduction of this interactive live session, as discussed several times, is to maintain discipline by the learners. All the learners are required to type in their names with enrollment number and program name to mark their attendance. Okay, in the chat, and you can raise your questions after the completion of the session. Try and avoid posting relevant questions. Okay. So, coming to the learning objectives for this session, by the end of the session, the learners will be able to understand about what are arrays, why we need them in during for programming, what are the different properties and the characteristics of arrays, how to declare an array, how to initialize an array, what are the different terms which are associated with array like element, index, okay, subscript, right? Then we will try to declare one-dimensional array. We will learn about one-dimensional and two-dimensional arrays, how to declare and how to initialize, how to use one-dimensional array, okay? And then we will see several programs related to the array and their initialization, declaration, and usage. Okay. And we will also see different methods by which we can modify and manipulate the elements of an array. So this is the objective for today's session. Uh, I have given a brief introduction about array in the last lecture, but we are going to revise in this lecture what we have learned. Okay. So about array. So what is an array? It is a collection of data items which belong to the same data type. Okay. And how are these data items stored? As you know that when you declare a variable, what happens? What happens when you declare a variable? Where does the value get stored? So the value gets stored in a memory location. You all know this. Okay. We have got a RAM. We have got a set of memory locations, which we called memory. And one of these locations is used to store an element. And that element is the value for which we have given a name. And that name is called a variable. So we can also say that a variable is nothing but a name given to a memory location, a label which is associated with the memory location. That would be the most appropriate definition of a variable. Okay. So how do you declare variable in C language? C is a strongly typed language, means it is necessary to declare the data type with the name of the variable. Okay. So if you want to declare a variable, how do you declare a variable? Int a. Okay. So by doing that, what have you done? You have reserved 2 bytes of memory for storing whatever value you assign to a. So suppose in the next line you write a is equal to 2. Okay. Or you can club the declaration and the assignment in the same line. That also you can do. Okay, you know this. For example, you write here int a is equal to 2. So that is also one way of writing it. But whatever declaration and initialization you are doing, what happens after initialization? So this value 2 is stored in a memory location. Okay, so this value is 2, which you have stored here. And the name given to the memory location is called variable, which is a. Right. So whenever you will use a, you can access the value which is stored at its memory location, that is 2. This is what happens when you declare a single variable. Now imagine we are going to declare multiple such variables which belong to the same data type. For example, I am declaring here int a is equal to 2, let's say. Then I am declaring int b is equal to 3. Then I am declaring int c is equal to 3. Or to the best of my programming knowledge, I can write int a is equal to 2, b is equal to 3, or c is equal to 3, 4, or whatever, right? I can write like this. But have you noticed one thing, that I have to declare different variables and give them, or like assign them value separately. And there is no guarantee that these memory locations will be contiguous. Contiguous means which are placed subsequently one after each other. That is called contiguous. For example, I have given example of coaches in a train. So what about coaches? For example, there is a coach called A3, and then there is a coach called A2. Okay. So it means you will expect A2 after A3, right? So these are what? These are the locations of a train. Okay, you can store values in it. So they are contiguous. Contiguous means occurring one after the other. Okay, there is no gap between them. But if you declare these variables separately, what will happen? B will be here, C will be here, or maybe further down the line, C might be here also. So to avoid this all, we declare a single variable, which is called an array. So array is a collection of memory locations. Okay, it is a collection of memory location, or we can say it is a homogeneous collection. What is homogeneous? Homogeneous means all the data types, all the values will belong to the same data type. So it means that you can declare an integer array. If you declare an integer array, all the elements of this array will be of type integer, right? In the same way, if you declare a float array, it means that all the elements, all the values which you are going to store in it will be of type float. So that makes an array a homogeneous collection. Homogeneous collection means all the values belong to the same data type, right? And all these values are stored in contiguous memory locations, means one after the other. For example, if I name this array location as A0, so it means that this is the 0th memory location. We always start counting from 0 when we designate memory locations inside an array. So the first memory location or the first location in an array is indexed with 0. Okay, so the next memory location will be A1. So let's say you have 10 such memory locations. So, and if you start counting from 0, the last memory location will be A9. Okay, so the first memory location will be A0 and the last memory location will be A9. So I hope you notice that I have mentioned all the indices in square brackets. So these are indexes. Indexes means locations. Okay. So array can store an array can store a collection of derived data types also, and array is a derived data type in itself, means it is derived from a primitive data type. Primitive data types like integer. So if you create an array, it can be only of the primitive data type. You can create integer array, you can create character array, which we call string, we can create double array, we can create float array. Okay. And if you want to access a memory location, you have to mention its index number. For example, like roll numbers we have, or if you want to access a certain coach, we will call it by a certain number, that coach A3, coach A2, coach A1, like this. Okay, so, and what is the advantage? All the values which you are going to store will be stored contiguously. Contiguously means one after the other. Okay, but if you declare variables separately, they will be stored in non-contiguous memory locations. Right? So I hope you got the concept of what is an array. So what is the need of array? We use array in programming to store a collection of data elements of the same data type. This I have already told you. Then you can store and access multiple data elements. You means you can create different data elements and store it at a single memory block. Okay, and you can easily manipulate it. For example, I want to change the value of the third value. So I will write here A2 is equal to whatever value I want to give. So instead of, let's say, 3, I want to make it 5, or 4, I want to make it 3. So I can index it. So what will happen? Let's say I have got these three locations. A0 is storing 2, A1 is storing 1, and A2 is storing, let's say, 3. So if I write this statement, A2 is equal to 5, what will happen? Instead of 3, it will store here 5. So it can reinitialize the value. The entire array is called A. Okay, and the name of the array will point to the first memory location. Okay, so name of the array will always point to the first memory location, which is the starting memory location. So by doing this, you will not leave spaces between memories. So by that, you will use your memory efficiently. Means there will not be holes or there will not be gaps in between the memory. Okay, and it is also easy to implement any algorithmic concept or any loop structures on arrays. So for example, you want to retrieve all the values stored inside an array by using a loop, you can easily do that. You just have to run a loop from 0 to 2. So by mentioning all the indexes using a counter variable, you can initialize i's value as 0, 1, 2. Okay, you have studied loops, so we will apply loops for accessing values for arrays. In the same way, you can store values easily inside an array. And by this, the program structure becomes simple. Right. So these are the different advantages, or I can say reasons for which we use an array. So there are different properties or there are different attributes which are associated with arrays. First is arrays fixed size, means it is not like that you can extend array as much as you want. So it is a static memory location. So once you declare the size, only that much memory will be booked for you to store values. For example, you have declared an array of size 10. Okay, so it means that a memory block containing 10 locations will be reserved for you. Okay, so now you can store 10 integer values inside this array called A. The first value will be stored at location A0 and the last value will be stored at location A9. Okay, then it is a homogeneous collection. You know that homogeneous means all the values, all the elements which are stored in an array belong to the same data type. Okay. Then indexing means we start this index with 0 and goes till n-1. Now what is n-1? So if size of the array is 10, then the last index will be n-1. So if I have got an array of size n, the last index will be of value n-1. For example, if the size of the array is 10, the last element will be n-1, that is 10 minus 1, that is 9. Okay, and you always start counting from 0. So if you go from 0 to 9, you will have 10 memory locations inside your array. Okay, now what is dimension? Dimension means how many indexes we can use to access a memory element. So here we will have only a linear collection. So all the values are stored in a line by line structure. So it is a one-dimensional matrix. One-dimensional matrix means you can grow your array only in one direction. Okay, but if you have got two-dimensional array, what will happen? It will be of a tabular structure or a matrix-like structure. So here you can grow your elements in two directions, row-wise, column-wise. Okay, so this is column and this is row. So if you create an array of 2 dimensions, then you will have to supply two indexes to access one value. For example, you want to access this value. For accessing this particular value, you have to give column number and the row number. So column number here is counting from 0, column number is 1, and counting like this, the row number is also 1. So if you want to access this value, you will have to write A11. Okay, so A11 means how many indexes have you supplied here? 2 indexes. So if you are supplying 2 indexes, the array becomes 2-dimensional. If you supply 3 indexes, the array will become 3-dimensional. Okay. Then contiguous means I have already told you that all the values will be stored in contiguous memory location, means one after the other. Random access means any element can be randomly accessed. You just have to specify its index number. Okay, but if you give an index out of bound, means let's say I give index as 10. Do we have index 10? In this size from A0 to A9, there is no index 10. So it is an array out of bounds or index out of bound. So index out of bound means what? Out of the 10th index does not exist. Okay. So let's understand the use of array through a use case. So we can have a small number of elements. We can also use array to store large number of elements. Okay. For example, I want to print 1 to 100 numbers. So in C language, we can have two approaches for that. Either I will declare 100 variables, and for every variable I assign it from 1 to 100. For example, I have variables like a is equal to 1, and then from Z to 26, and then A1 will be 27. Okay, then still Z1 it will be 52 likewise. So by doing that, how many variables I have to make? I have to make 100 such variables. Is it a good way of implementing program? No. Okay, so the best way will be to declare an array of size 100, and we will store values in the loop. So start from A0 and the last value will be A99. Okay, so that is programmatically more effective. Okay, and by using a loop, I can access values from A0 to A99. So so my I index will lie between 0 to 19. So by using an array and a loop with it becomes more convenient programmatically, right? So this is a small use case by which we can appreciate why an array is a better solution for storing values, large number of values. Okay, in memory, we can represent an array as a contiguous block of memory locations, and they have a fixed number of values. So here, you can see here, I have created an array of size n. So the first index will be named as 0 and the last index will be named as n minus 1. So the name of the array is numbers. Okay, the name of my array is numbers. So let's say I have declared an array called numbers of size n, of any size you can use. Okay, so let's say I have created a number of size 10. Okay, so what will be the first element? Where the first element will be stored? In numbers 0. And where will be the last element stored? In numbers 9. So in numbers 9, the last element will be stored if my array is of size 10. Okay, so lowest address corresponds to the first element and the highest address corresponds to the last element. So if this index is higher, we are going towards the last element. If this index becomes smaller, then we are going towards smaller element. So we can also traverse this array. Traverse means to move in the array. So if my index is decreasing, I am going from the last element to the first element. If my index is increasing, then I am going from first element to the last element. Okay, this is called traversal. Okay, so movement in the array is called traversal. So array can be represented in different ways, right? So we will see how to declare an array. So here I have already told you that array can store only the same type of data items. So this is an example where we have created an integer type array. Why it is an integer type array? Because all the values which are stored here are integers. Okay, so array A is a integer type array. Now what about array B? What do you think about array B? So array B is only storing character type values because every single element present inside this array is of type character or char. So that makes the data type of the array as character type. So this array is of character type. Okay, because all the elements which are present in this array are of type character. So, but what about array C? Can such an array exist? Can an array like C exist? It cannot, because you cannot have heterogeneous collection and it is not permissible inside C language. It is not permissible in C language to have heterogeneous collection of values inside an array. So it is a mixture. We are having character type values here, we are having integer, we are having float type value, not allowed. So it is wrong. So C will not permit creation of such an array having mixed data type or heterogeneous data types. Okay, so someone has pointed out that the data types are mixed, but that is not sufficient. You also have to say that this is wrong. Okay, it is wrong because array is supposed to be a homogeneous collection of values and not heterogeneous collection. Okay, so I hope you are able to understand the concept of array till now. Okay. So here now we are going to understand how to declare an array in C language. So we will write a statement like this. So in this statement, let's do the analysis of this statement. So what does this analysis tell us? That first we have to mention the data type. The same way we declare variables. So how we declare variables? Int a is equal to 2, right? So here first we have to mention the data type. Then we have to mention the name of the variable. So name of the variable is array. Okay. But since array is a collection of values, I have to specify size of the array because it is a fixed length variable. Means it is a static memory location. So size is important here. So I will mention here size. Though you can, it is optional, but if you are mentioning size, that's how we write it in square brackets. So square bracket will tell us that we are creating an array. Okay, then if I want to initialize this array, I can also leave my statement here. That would be called as declaration. But I am mixing declaration with the initialization. So if I'm doing declaration and initialization in the same statement, then I have to use assignment operator. So assignment operator will allow me to assign a set of values to the array. Okay, so here I have assigned some set of values. I can store less number of values, equal number of values to the size, but I cannot store more number of values than 10. So maximum permissible limit of storing values inside this array is 10. It is allowed that I can store less number of values. Okay, the remaining values will be assigned 0, which is the default value of integer. But I am here storing exactly 10 values inside this array. So I am using the entire length of the array. So if I do that, then all these indexes will be mapped against all these elements. So these are the elements which I have stored in the array, and they are positioned according to the index. So the smallest index will have the first element and the largest index will have the last element. As discussed in the previous slide, the smallest index will have the first element and the largest index will have the last element. Okay, so here the first element uh, will be accessed by index 0. So if I write here array 0, so which value will I access now? Which value will I access now if I write this statement array 0? The first element, right? So the first element is 35. So this value is 35. If I write array as array 7, now which value will I get here? 44. Yes. So I will get 44. And then what about the last value? Array 9 will get me the last element. Okay. So the data items which are stored are known as elements, and the positions where they are stored are known as indexes. The plural is indices. Okay. So hopefully till now you are able to understand how we store values inside an array. So when we declare an array, we have to use this syntax. So first we have to mention data type, then we will write name of array, and then the size of the array. So I am just talking about declaration, not initialization. So when I simply do declaration, I will put semicolon here. So this is purely declaration, no initialization. Okay. So let's say if I'm going to declare an array as ARR. So what will be the declaration here? I will write here int array ARR. Okay. So if I write int array ARR, then the ARR is of type integer. Okay. And the size of the array is 5. So it means the maximum elements that it can store is 5. Right. And the indexes will be provided from 0 to 4. Right. 0 to 4. So here the size of the array has to be mentioned inside the square brackets. So here let's take an example for integral values or integer values. I have declared an array of type integer. The name of the array is A and the size is 10. Okay, so I can here store 10 values. Similarly, I want to declare a character array, let's say B. So all these elements will have character type values. Okay, so these are all character type values. Okay, characters are enclosed in single quote marks. Right. So now the declaration the part is over. Now we come to initialization. So initialization means I'm going to assign values to the array depending on the size. So the size is the maximum permissible limit for the amount of values which I can store inside an array. Okay. So if I don't assign and a value to the array, it can have a garbage value. It can have some trash value, which it doesn't make sense. Okay, so we use curly braces to mention the list of elements I want to assign, and all these are separated by comma. Okay, so value 1 comma value 2 till value n. So here I have created an integer array ARR of size 5. So all these elements 2, 4, 8, 12, 16 I want to store in it. So I will separate them by comma and put them in curly braces and then put a semicolon. So by doing this, I have initialized my array. If I want to split the declaration and the initialization, I must have written this at the beginning. Okay. Right? I must have written this statement in the beginning. So after initialization, what happens? At the 0th index, the first element which is 2 is stored, and at the 4th index, that is the last index, the 5th element 16 is stored. So this is one way of doing the initialization. I am not saying that this is the only way of doing initialization. There are like other ways by which we can do initialization. So here, the second approach for doing initialization is declaring without size. So it is also possible that I don't mention the size. But here the size is automatically inferred or deduced by the compiler, depending upon the number of elements that you assign to it. So if I don't mention the size here, there is no size that I have provided. So how does it come to know about the size of the array? Depending upon how many elements you are trying to store in it. Okay, so since you are capable of storing 5 elements inside the array, the size of the array should be 5. But you don't need to write it here in the square bracket. If I write it 5, that is also okay. If I don't write 5, that is also okay. Okay, so if I don't write 5 here, then the size will automatically be inferred by the compiler, will be deduced by the compiler as 5. Okay, so this is another way by which we can do initialization without specifying the size of the array. Okay, I hope you are able to get that why mentioning size is not necessary. Okay, then we have got the third approach for initialization, that is by using loops. So by using loops also you can initialize your array. So for that you have to put a loop structure like for, and then you declare a counter variable or a loop variable and initialize it to 0, and take any value as n. Let's say instead of n I write here 10. So the loop will run from 0 to 9. Okay, so loop will run from 0 to 9, means it will keep on assigning values for locations a0, a1, a2 till a9. So every single memory location or every single array location will be referred as AI. So here A is the name of the array and I is the index, which is a counter variable in the loop. So whatever value I gets during the iteration will be used as the index for accessing that element inside the array. So that particular element or that particular index can be assigned with some value. Okay. I hope you are able to understand this. So here I will start from, I will acquire values from 0 to 9 because 9 is the last value which is less than 10. Okay, since n is 10 and this n will be the size of the array. So whatever size of array you want to create, that value you will assign here for comparing with I. Right. So by using for loop, while loop, any type of loop, you can do initialization. So let's take an example of assigning values via loop and by all other three ways. So by using the first approach, this is the program which entails all the three approaches of the like array initialization. So the first approach of doing array initialization is by mentioning the size and assigning value in the curly braces. Okay, that is quite simple. Here I have mentioned the size and these are all the elements which will be stored in this ARR array. So ARR array will have all these values, right? They will be stored here. What are the values which I have stored here? 10, 20, 30, 40, 50, right? So this is ARR 0. And what about this number? ARR 4, right? So like internally it is stored in contiguous memory locations. In this other example, in this other statement, ARR1 is the name of the array. But here I have not specified size, but it will infer it automatically. How? By looking at number of elements. So since the number of element is 5, the size here is like automatically calculated as 5. So I don't need to tell it. The similar representation will be there for ARR1 also. So ARR1 will have size 5 and you will store 5 values in it. Okay, so this is ARR1 0 and this is ARR1 4. Okay, how does it come to know about the size? Again, by looking at number of elements which we are storing in it. So without specifying size also we can initialize an array. Now coming to the third approach using a loop, I have created another array of type float named as ARR2. I have also given the size, that is 5. Now I am running my loop from 0 to 4, means value less than 5. So for i's value ARR2 of I, what will be the value? So when I becomes 0, ARR2 I becomes ARR2 0. What is the value which we are storing it here? I multiplied by 2.1. Okay. So that is typecasted into a float value. So you multiply the value of I you typecast this value of I to a float number, which will make it 0.0. So 0.0 multiplied by 2.1, what will be the value? What will be the first value which we will store is 0.0. Okay, so the first value which will be stored at ARR to 0 will be 0.0, because 0.0 multiplied by 2.1 is 0.0. Now in the next iteration, I will become 1. So the next element will be ARR to 1, whose value will be 1.0 multiplied by 2.1. That will be 2.1. So the next value will be 2.1. So the next value will be 2.1. 1.0 multiplied by 2.1 is 2.1. Next, I will be incremented to 2. So ARR to 2 will be 2.1 into 2, that is 4.2. So the next value will be 4.2. Then for 3, what will happen? 2.1 into 3.0 will become 6.3, right? So the next value will be 6.3, which will be ARR3. Last value will be 4. So ARR to 4 will be 8.4, right? So the last value will be 8.4. This will be the last value, ARR to 4. After 4, it will increment and become 5, which is not less than 5. So it will come out of the loop. Okay, so Manoj Kumar has given right answers. Right. So hopefully you are able to understand. And you forgot the first element, that is 0.0, right? That will be stored at the first location. So hopefully all the learners have like understood this program, how array initialization was done by 3 approaches. First is mentioning size, second is without mentioning size, and third via the loops. Now coming to the type of arrays. So there are 2 types of arrays, one-dimensional array and multi-dimensional array. What is dimension? Dimension is how many indexes you are using to access the array, or in how many ways you are growing an array. Okay, so if you are using only one index, if you are only mentioning A10, A2, A3 like this. So if you are only using one index, that makes your array as one dimension. So one dimensional array is also known as linear array, or we can also call it as vector. Okay, so it is a unidimensional array. When it comes to multidimensional, let's say 2-dimensional array, then you will use 2 indexes for accessing your values. So if you are using 2 indexes for accessing your values, your array is a 2-dimensional array, which is also known as a matrix. Okay, so 2-dimensional array we use. 3-dimensional array also you can use, and but growing the array more will become more complex. It will your structure will become too much complex. So we normally study 1, 2, and 3-dimensional arrays. Right. So here, as you can see in 2-dimensional array, you have to mention the row and the column values. So the first value that you put here is row and the second is column. So that makes a matrix. Okay. And for each of the dimension, you have to specify the size before. Okay, so the size, let's say you have an array of size m cross n, or you create a matrix of size m cross n. M cross n matrix is there, let's say. So it means it will have m number of rows and n number of columns. Okay, let's say you have got a matrix of size m cross n. So it means m is number of rows and n is number of columns. So let's say your rows will start from 0 and go to m minus 1, and your columns will be from 0 and they will go to n minus 1. Okay, so the last the last element will be at index m minus 1, comma n minus 1. Okay. And the first element will be at 0, comma 0. So the first element will be placed at 0, 0, and the last element will be placed at m minus 1, n minus 1. Okay, so I hope you are able to understand this thing. We'll study about two-dimensional array more. So now we come to accessing array elements. So for accessing array elements, you have to mention the index. We always mention the index. For example, you are looking for your friend in a train. How will you access your friend? If you know the coach number, it will be easier for you. If you know the coach number, it is easier for you to locate your friend. So it means that if you want to access any element inside an array, you have to know its index. If you know its index, then you can access that element. Let's say you want to access this element. So this element, if you want to access, what value you will pass in ARR? ARR 3. So ARR 3 will fetch you this element. Okay. So this is called subscript operator. This pair of square bracket is called a subscript operator, in which we mention the index. Okay. So here we have an example program where we are accessing array. So let's say we have declared an array of size 5 and we have stored here 5 elements in it. And I want to access the element at index 2. So what will I print? I will print element at ARR2 is %d, and %d will be ARR2. So what is the value which is placed at ARR2? 35. So it will print 35. Similarly, I want to print the element at index 4. So I will write here printf element at ARR4 %d. So %d means single integer value, right? So here I will put ARR4. So it will print 55. Okay, so this is ARR 4. This is ARR 2. This is ARR 0. Okay. Similarly, I want to access element at index 0, which is ARR 0. So it will print 50. Clear? So now you can print the values by using the format specifier. And here you will use the, if you want to store values in it, you will use this ampersand, which is called address of operator. The same way we used in single variable. So every single element is a single variable. Every single element in an array is treated as a single variable. Okay, so advantages, disadvantages, you can easily traverse the array, means you can use in both directions. You can sort it, you can search for an element. The code is optimized, means you have to use less number of codes, less lines of codes. You can randomly access values inside an array. So these are all the popular advantages of array. Disadvantages are static allocation is there, means once you set their size, it cannot increase or decrease. Okay, for that we have to use dynamic memory allocation techniques like malloc, calloc, those functions we use. Okay, but array is a static allocation. Okay, so since it is static allocation, it will only allow fixed number of elements to be stored in it, and array is not dynamic. Okay, if but you can create a linked list which is dynamic. Insertion deletion can be costly, because costly in terms of time. Okay, and space. So elements will be have to be rearranged after insertion and deletion. So now we start with the two-dimensional array. So what is two-dimensional array? Two-dimensional array, I have already told you, it's a matrix. This is one-dimensional array. Okay. So this one dimensional array will only store values in single dimension, means only progressively from 0 to 8. Let's say I have got an array of size 9, so it will index from 0 to 8. Similarly, in two-dimensional array, we need pair of indexes. So the first value will be row number and the second value will be the column number. So the first element will be at row number 0 and column number 0. So if I write here, let's say I name this array as ARR. So if I write here ARR 00, I will get this value. Okay. If I write here ARR 11, which value will I get? This value. Right. If I write here ARR 22, what value will I get? This number. Okay, so I'm using two indexes for accessing a value. So that makes the array as two dimensional. Or I can say in other words that the like path in which or the direction in which your array can grow is two. That also means that my array is two dimensional. Okay, so I hope you have understood the concept of two dimensional array. So we can also say that a two-dimensional array is array of arrays. So if we look at a two-dimensional structure, it is one-dimensional structure put on top of the other. So let's say this is ARR first array. This is put over other array. This is put over other array. Okay, so these are the arrays which are stacked on top of each other. So if this array is stacked on top of each other, we can call it an array of arrays. So if I look this entire structure as a big 2D array, so 2D array is made up of stack of 1D arrays. So it is a stack of 1D arrays. It's a pile of 1D arrays. So every row can be treated an array in itself. So that is why we call 2D array as an array of arrays. But if we look at holistically, we can see that it is a table. It's a matrix. So the first element is at column 0 and row 0 and it is indexed as 0, 0. So here we are using two subscript operators. Since we are having two indexes, so we are having two subscript operator, one for row and the other for column. Okay. So first we mention row number and the second we mention the column number. Okay. So if I look at this 3 cross 3 matrix, so this is a 3 cross 3 matrix. So here the first value will be 0, 0 and it will go till 2, 2. Okay. So this is 0, 0, 0, 1, 0, 2. Means 0th row, second column, 0th row, first column, 0th row, 0th column. This is 1, 0. First row, 0th column. Okay. First row, first column, first row, second column. What about this? Second row, first column, second row, second column, second row, third column. So, sorry, third row, third column. So it was ARR 2, 2. So if you say that your matrix is of size m cross n, the last value will be m minus 1 and n minus 1. So if your matrix is 3 cross 3, the last value will be 2, 2. Okay. 2, 2. The last value will be 2, 2. Okay, is it clear? So how do you declare a two-dimensional array? For declaring a two-dimensional array, same thing, just mention two indexes. Data type, name of array, the number of rows and number of columns, and put a semicolon. So by doing this, you can declare a two-dimensional array. For example, I want to declare a two-dimensional array with 5 rows and 3 columns. I will write here first subscript as 5 and second is 3. So what will be the structure it will make? What will be the structure it will make? So it will make a structure like this with 5 rows. Okay. So it will make 5 rows. So let's say this is the first row, second row, third row, fourth row, and fifth row. Okay. And how many columns do we have? Three columns are there. So three columns are there. So it will create a structure like this. So the first value, the first memory location will be the name of the array, my array, let's say. So it will be 0, 0. This will be 0, 1. This will be 0, 2. Okay. So likewise, it will go on. What about this one? It will be ARR 4, 0. Right? What about this one? This will be ARR 4, 2. Okay. So this is how they will be indexed. And you can use these like indexes for storing any value. Okay. Is it clear? So this is how it will create a structure like this. So this is the 0th column, first column, second column, and then this is row 0, row 1, row 2, row 3, row 4. So this is how it will be structured. Okay, so this is how your array will be created inside the memory, and you can use for loops. But now in for loops, you have to use a nested for loop. Okay, so that we will be studying in the next lecture. How will we use nested for loop for accessing the values inside this two-dimensional array? So depends upon the dimension of array, the number of nesting in the for loop will increase. So it will be like for I is equal to 0, 0, I less than, let's say, m number of rows are there. And in this loop, you will write here for j is equal to 0. Okay. And then you have to go for j less than n for every column of the mth row. Right. So likewise, you have to write the loop. So if you increase your like array in the dimension, the complexity of the program will increase. So this brings us to an end of the lecture delivery. Now it's time for some review questions, which I would like to ask to my dear learners for assessing their understanding. So who can tell me what are arrays? Okay, define array. Write in chat, please. Don't use Chat GPT or Google for answering. Just what you understood. No need to use Chat GPT or Google for these trivial questions. Okay. Write in your own words. What have you like understood about array? What is an array? Please be interactive during this session. Okay, array is a contiguous memory locations. Okay. What else? You have only addressed one feature of array. First of all, you have to write array is a derived data type. Okay. The first thing which should come into your mind is array is a derived data type. Right? Means you can create an array from primitive data types. They are derived from primitive data types. What else? This is the first thing. Second thing, you are absolutely right that it is a collection of contiguous memory location. Perfect. Then what is the third feature? Most important thing about data types. No one is answering, only Manoj is participating. What about others? Divya Jyoti, Akash, Riya, these students, Arush. Netal, Jasjeet, Ekta. No one is replying. Bhavesh, Shani, Sanjana. Please reply. Samartha was also replying. Salman. Yes. What is the important thing about data types? I'll ask other question. First, you answer this question. Accessing data from anywhere. How how will you access data in an array? What is required for accessing data? If you want to access data, index. Yes, very good. Data type is that doesn't make sense. Means same type of data type. You want to say this? Same type of data type values can be stored in it inside an array. Okay. So how do you declare an array? How do you initialize an array? What are the different ways of declaring an array? Yes, Ria, you can answer this question. Jasjeet, Divyesh. What are the different ways of declaring an array? Okay, mentioning size, not mentioning size, mentioning index. Okay, mentioning size. Yes. How can you type your answer by mentioning size? Int array 10. Very good. Put a semicolon at the end. Okay. Yes. So this is how we initialize arrays. So it is necessary to mention the size of the array during declaration. Now, what about initialization? What about initialization? How many ways we can initialize? How many ways we can initialize? So there are three ways in which we can initialize. First, we mention the size, put curly braces and put number of elements. Okay. What is the second way? No need to mention size. Okay. Without mentioning size also. And the third way by using loops. Okay. By using a loop, using while loop, for loop, do while loop. By using any loop, we can access values inside array. Okay. What is dimension of an array? What is the dimension of an array? Okay. So number of indexes used. Okay. So the learning outcomes are we have understood the need of arrays, properties, declaration, initialization of arrays, types of arrays, and accessing values of arrays. Right. So this is we come to an end to this lecture. Thank you and happy learning.